Hello all, I am Meenakshi. So now we'll discuss divide and conquer strategy, design strategy, one of the important algorithm. So here entire problem is divided into several subproblems of the same type, and once we split the problem, then those subproblems are solved recursively through sometimes a different algorithm or same algorithm. And then once we got the solutions for subproblems, these subproblems are combined together. If you see the diagram, how it works, we'll refer Anthony Levitin textbook. The problem is of size n. We are dividing into n by 2, two splits, and independently, recursively, we are finding the solutions for these subproblems. And finally, we are merging into one that gives the solution for original problem. This is a design strategy of divide and conquer technique. We have to see one example now. So let us consider problem of computing sum of n numbers. Say for example, numbers are starting from a0, a1, etc. up to an minus 1. These are numbers we need to compute the sum. If n is equal to 1 means there is only one number and that number itself is the answer. If not, if total number of elements more than 1, then we need to divide the problem into two instances of the same problem. Then recursively you find the sum of those subproblems and get the solution. So that is nothing but say 0 to n minus 1 numbers splitted into a0, a1, etc. up to n minus 2 minus 1, and second part is nothing but a n by 2 starting point ending with last number n minus 1. And so these subparts again recursively splitted again and again. How long? So whenever the number will become 1. So total number of elements in the sub portion, sub array will become 1. So that means if n is equal to 1, the answer is that number itself. So here we should note down, not every divide and conquer algorithm is necessarily more efficient than brute force approaches. Sometimes the time spent on executing the divide and conquer plan turns out to be significantly smaller than solving a problem by different method. This approach yields some of the most important and efficient algorithms in computer science. It is ideally suited for parallel computations also. So related to this, we should see one important algorithm, that is master theorem. So by this, we can find the efficiency of any divide and conquer algorithms without having calculating the recurrence relations. So no need to solve those recurrence relations. Just by applying one theorem, we can find the time complexity. So let us start. Consider case of instance of size n. There are n instances which can be divided into size n by 2. So in general, this instance of size n can be divided into b instances of size n by b. So with a of them needing to be solved, that is nothing but, for example, if you consider some integers like this, we need to sort or we need to sum here. So we are splitting this in such a way that total there are 5 elements. So when we are dividing by half, and lower limit if you want to take, that is 2.5, its lower limit is nothing but 2, means 0 1 2. The first part will be like this and second part will be like this. So this is how we are dividing in every iterations. And if that is the case, so we are interested with time complexity of this design strategy, T of n, time complexity. So that will be a into T of n by b plus f of n. So this is one important formula. It represents general divide and conquer recurrence equation. So that is nothing but, so for example, in this case, once we split into two parts, our values for A and B we should find out. So A is nothing but, in sometimes, in some cases, we need to find the solution for couple of instances only. In this case, for example, we need to find the solutions for both part, means A will be 2. Number of partitions to be solved, that is 2 here in first iteration. And n by b is nothing but what, how many instances are there, how many groups we made, that is b value. So it is 2 in this case. So for final answer, we need to solve both partitions, that is indicated by a value, and how many partitions are there, that is indicated by parameter b. Okay, so a into time complexity for n by b plus f of n. So f of n is nothing but, it is a function that accounts for the time spent on dividing an instance of size n into instance of size n by b and combining their solutions. So that is nothing but, so this is recurrence part, this is non-recurrence part. So we need to divide the task, and also finally we need to merge the answer. So what is the additional time needed for this division as well as combining the results, sub problems, sub solutions, that is f of n. Okay, and here this equation, as we said, general divide and conquer recurrence equation. If this is the case, now we should come to the master theorem, which says that if this second part, that is additional work for division and merging of the solutions f of n, if complexity of this second part f of n belongs to theta of n to the power d, if this is the case where d is greater than or equal to 0 in this equation, in that case time complexity for n instances belongs to theta n to the power d, first case, if a is less than b to the power d. So it is n to the power d log n if a is equal to b to the power d. Last case, so t of n, time complexity, belongs to theta n into log a base b if a is greater than b to the power d. So we should observe here f of n here. So this is anyways fixed. We are keep dividing the problem into sub instances. How many problems, sub problems need to be solved? A. And what is the instance size? B. And what is the additional effort or complexity required for division as well as combining the solutions? So f of n. So based on complexity of f of n, we are trying to get the time complexity of entire divide and conquer method. So that is the case. We'll see one example. So previously we had considered addition, and also always we are considering one assumption, that is total size n is nothing but can be represented in terms of 2 to the power k. That is a reference or assumption we made for easy computation. Now, without solving recurrence relations using master theorem, how we can compute the time complexity of this sum problem? So here, so addition of n instances is equal to how many partitions in first iteration? 2 partitions of size n by 2 plus 1. So that is nothing but, so carefully we should see here, we should compare to our previous example. So we should come back to this basic formula and get the answer of A and B first. So that is nothing but a is 2, b is 2 here. And f of n is equal to 1. So f of n, you see f of n is equal to 1. It is nothing but for the addition of n numbers, additional complexity or overhead required for division and summation of subproblems is 1. That means to say it is a constant. Whatever the size of n here, how many partitions we made, irrespective of size of the inputs, so constant time is required for adding subproblems. That is the meaning of f of n is equal to 1. It is non-recursive portion of the t of n. If this is the case, so what the starting point of master theorem says that f of n belongs to theta n to the power d. So here we should write f of n belongs to theta n to the power d. For summation problem, they say that f of n is equal to 1 additional overhead or complexity of a division as well as summation of subproblems. So if we compare carefully these two things, we'll understand that n to the power 0 will give 1. Right? N to the power 0 will give 1. So that is nothing but, so d value is 0. So we have values now coming back to this. A is 2, B is 2, D is also 0 value here. That means you apply for these A, B and D values, we'll come to know that A is greater than B to the power D. A is 2, 2 to the power 0, that is 1, 2 is greater than 1. So if that is the case, directly we should apply here the complexity of this entire equation. This entire equation is nothing but n log a base b. So that is n log a base b is nothing but n log 2 base 2. So that is n, theta n. This is the complexity for adding n numbers using divide and conquer method. So what we did here is earlier we used to solve these problems recursively by substitution methods, the complex method. But here in this case, using this master theorem, these three steps, master theorem, we concluded that summation problem using divide and conquer method belongs to theta of n.